Good morning. Hope you're doing okay. Let me know if the audio is okay. I just streamed a second ago, but that doesn't mean it was good then either. But we're going to get started in on learning JavaScript. Let's see. For some reason, my camera looks all wonky now. I don't know what's going on, but I guess we will try. Try turning it on and off and see if that fixes it. So before we get started here, nope, that didn't fix it. So you might just have to watch me squashed. Or I can try to refresh it again. Let's see what we can do. There we go. I don't know what was going on, but all right, now we're set and ready to go. Let me know if you can hear okay. And then I'll switch everything over here in a second. Audio's good. Thanks, Jude. Appreciate that. Okay, cool. So let me come over here. I'll move everything around so that we can actually do the things we want to do. And then let me transition over. We're going to jump straight into Eloquent JavaScript again. And maybe I'll even be slightly more awake since I just streamed. Hey, hope you're doing okay. Let me know if audio, like music, is okay too. It looks like it might be a little loud, so I turned it down a touch. But let me know. Okay, so here we are in Eloquent JavaScript. We've been making our way through this book, which has been great. So far, we've looked at values, types, operators, program structure, functions, and data structures, objects, and arrays. So today we're looking at higher order functions. I don't know if we're going to get through all this because there's a lot here. Then there's, a lot left to go as well. So we're mostly just looking at kind of the basics of JavaScript right now. So this is more for beginners in JavaScript, but I'm happy to kind of chat through and add kind of some extra stuff as we go through this, but hopefully this will be a help to you. So let's jump into higher order functions. A large program is a costly program, not just because of the time it takes to build, not just because of the time it takes to build. Okay, that was a sentence. Size almost always involves complexity. And the more complex you get, basically what you need to do, excuse me, what you need to do is often find abstractions to make things feel simpler when you're actually using the program. And that's essentially what we're talking about today. So they gave two examples here. This first one, we looked at this early on, where you take a total and then you have a count and then you do a while loop and then you console log that out, right? So this is a kind of a self-contained section here. They're saying which one is easier, this right here, or this one here that simply finds the sum of this range. And they're saying which one of these is more likely to contain a bug. Well, here you've got all the stuff that you're writing. Here you're using this kind of built-in method. And so I'm assuming like the simplicity of this is what they're arguing for, all right? So the definitions of this vocabulary, the functions sum and range, will still involve loops and counters and all that kind of stuff. But because they're expressing simpler concepts in the program as a whole, they're easier to get right. So when you're actually using this, you'd rather use this than be like, no, wait, what is this doing? Okay, and you have to almost read the program to figure it out. Whereas when you make these abstractions, in this case, JavaScript's made the abstractions for us, this allows you to basically interact with, let me make sure I can see all the chat. Yeah, okay. It allows you to interact with your program in a more predictable way. So let's work our way through. They give this other example here. I did read most of this chapter ahead of time, but unlike the last couple times. So they're saying which one's easier to read as a recipe, all of that or this? Well, this is a lot easier to read, but it also assumes you know some things. For instance, assumes you know like soak and simmer and chop. And so these are the kinds of things it's assuming you know, whereas this explains each individual thing. Like here's what it means to soak. So when you're writing abstractions, you have to basically figure out what level of knowledge is the person using this code going to have so that I can use that knowledge and not have to kind of re-explain all that or make them provide it for me. So the second is simpler and shorter and easier to interpret. And so that's what we're thinking about here, okay? So when we have repetition, plain functions, as we've seen so far, are good. Plain functions essentially do one thing and one thing only. It's common for a program to do something a given number of times. So you can write a little for loop like this. Let I equal 0. We've done this a couple times so far in this series. So can we abstract doing something n number of times? Yeah, you can. It's called, we'll call it like repeat log. So we're going to repeat something and we're going to log it an n number of times. Now, when you're actually calling this, instead of writing this every time, you can just call repeat log n, right? So if I were to come down here, this isn't going to do anything right now because we haven't called it, right? But if I come down here and we say repeat, log, so I'm actually calling the function now, and I'm going to pass it something. So I can say like hiya, all right? And then if I go ahead and play it, if it'll let me do anything here. Did I not spell this right? No, I did. Okay. So let's do it ourselves since it's being weird. And I'm not sure totally what's going to go on here. So why don't I run Quokka on this? Okay, cool. So I'm going to come down here. We're going to run this and I run hiya. So I should be able to repeat log and I pass it some kind of string or something. And each time it's going to loop through a certain number of times and log this. Oh, it's supposed to log I. Sorry, that's the reason. You have to actually pay attention to what the program does. So I guess this needs to be a number. So there you go. It's a number. All right. And it's going to log that so many times. Turns out reading things is super helpful in addition to making abstractions. So this would also have worked over here if I just read the function. But that this is a lot easier to call repeat log than having to write all this out or this out each time I want to do something. So if I make a nice little abstraction, I can just call my repeat log function, pass it whatever I want to log, and it will log that, right? In this case, obviously, this is not super helpful. Now, you can also pass along a specific action. That's what they're saying here. So if you were to run this, not only you're saying how many times to do something, n, but you're also passing along an action. And since functions, in this case, this console.log, can be a parameter you pass in, or you receive, an argument you send, then you can just pass the actual thing and say, hey, whatever I pass, do that, however many times I pass it in. So again, making this little abstraction makes that really, really nice. And we actually did look at like another way I like to do this that makes it a little bit cleaner even when you're calling it. So here's the function. Let's say I'm in a different section. And I'm just going to call this repeat stuff. And we're going to come down here where we can't see it. Let's say we're using this somewhere else. And I call repeat stuff. Right now, I don't really know what these things do. And VS Code is telling me like one of them is anything and the other one is anything. Well, that doesn't super help me. So what I would probably do is either use TypeScript, or what you can do is come in here and say like n, and then you can actually provide like this as an object. Now what this does is allows you to name these things. So if I say like number and then like function or something like that, now I can use both of these things, or I can't use function because that's a keyword. I can use func here. So this would be the func and the number would be right here. So you can see how what we're doing now is passing in an object. And the reason I like to do that is because now when I come in here, I can hit option and the space bar, or control option. Yeah, control and the space bar. And you see it actually tells me the exact things I need. I need a number, so I can provide that like 5 or whatever. And then I also need a function, so I can provide that console.log. And then I can go and run that, and it should print that out that many times, right? So this right here allows me to abstract out the actual names so that when I'm calling it, I know precisely the things I'm passing in. If we do it the other way, which is fine, you can totally do it that way. You'll see this way a lot. In fact, probably more often. Then I just have like for and console log. And I'm like, what are these things doing again? I just see the number 4. I don't know what it's for, right? No pun intended. So I typically like to use objects for that reason, but you don't have to. Both will work. Okay, so you don't have to pass a predefined function to repeat. Often it's easier to create a function value on the spot instead. So here we have labels, this empty array, and we're going to repeat 5 and push that into it each time, which will push unit 1, 2, 3, 4, 5. And if we console log labels after this repeat, this is what we'll have. This is structured a little like a loop for loop. It describes first the kind of loop and then provides the body. However, the body is now written as a function value, which is wrapped in the parentheses of the call to repeat. This is why it has to be closed with the closing brace and closing parentheses. So you see right here, this right here is a function, right? And this is a function block. We got those curly brackets. We've looked at that in the past. And it's simply doing this thing in the middle. Now, it's not actually returning anything out of this function. It doesn't give you anything back. But because it's modifying this array that's outside of the function, it's on the same scope level as here. We've talked about scope in the past, but basically I'm taking something and inside of this little loop, I'm doing something and pushing it into here each time. All right, higher order functions. And by the way, I just realized I changed the repeat thing. This function, I'm striking out already. This is an actual named function, which is why it wasn't console logging a second ago. I was wondering why that wasn't happening. Okay, higher order functions. Functions that operate on other functions, either by taking them as arguments or by returning them, are called higher order functions. So anytime you're passing a function to another function, or that function is passing you a function back, you're talking about a higher order function. That's just the name of them, but basically this allows you to abstract things and actually make more complex systems and simplify them for the person using them in the end, which might be you or another developer. So functions that operate on other functions, either by taking them as arguments or by returning them, are called higher order functions. Since we have already seen that functions are regular values, there's nothing particularly remarkable about the fact that such functions exist. The term comes from mathematics, where the distinction between functions and other values is taken more seriously. By the way, if you have questions, let me know as we go. You guys you all have been great about doing that, but yeah, just to know. Higher order functions allow us to abstract over actions, not just values. So we can actually use actions that we pass in or actions that we get back and use those in a more complex way. Okay. So for instance, we can write this function called greater than. We take in an n, and then here we're returning this complexity. All right. We're saying m, and then we're saying, is this greater than the thing I passed in, right? So here we could say, let's define a variable called greater than 10. We pass in greater than, and we pass in 10, all right? And this should console log, here I'm console logging 11, right? Now, what am I doing here? I'm actually defining a new function called greater than 10, right? That's what we're gonna call here. However, here I'm calling another function that's going to return the function I need. All right, does that make sense? So let's copy this over and play with it a little bit. I'll give you another example that is often used as well, if I think about it. So here what we're doing is we're defining a function, right? We're calling the greater than function. The greater than function gives us back a function. So if I hover over this, you'll notice VS Code is going to know that this is saying this new function that you created and happened to call greater than 10, it is going to take in any number. It doesn't tell me that it's a number, but I know it's a number, and it's going to pass back a Boolean, true or false. Now, the reason it can do this is because this is what this function does. It returns is m greater than whatever I passed in. And I've defined it and named it greater than 10 in this kind of way. So now I can pass in 10, I can pass in 12. Now I could create another function. So I'm going to use const because that's my default. I'll say greater than, we'll say 12. Obviously, this is not super helpful. Like you'd want to create it more abstracted than this, but this demonstrates the point. And I pass in 12 because this is the number I want to compare to. Now, if I come down here, actually, let's just take all this. If I can copy it, there we go. We can do greater than 12, and I can pass in 12, and it will say false, 13, true, right? I can go 9, false. So this 12 is its own little function here. And this is actually a new function, and it's been created by another function. So this function is basically a function generator at this point. Now there are generator functions too, but you don't need to know about that right now, all right? So basically this function is going to generate a function and pass it back to me. This is what we call a higher order function. So sometimes what you'll see is like, I don't know, a score, for instance, thing. So let's get rid of this. Let's create a function, and we'll create like a score. If I can do this, all right? So score, let's say it takes in a couple things. What do I want to do here? I want to keep this real simple. So let's just say it takes in a number, all right? The current score, whatever the score happens to be. And this is going to return me a function that takes in that number, right? Whatever the number happens to be. Actually, no, it's going to take in a new thing, right? So we'll take in like whatever new score, all right? So the new score that comes in, and all it's going to do is it's going to take my number and it's going to add to it. I mean, I can't type today. It's going to add to it whatever the new score is, right? It's going to pass that back to me. So this will pass back this value right here. So what I can do is go ahead and say like, let's have like game1 equals, and I'm going to call the score function, or maybe we could do like make score or something. I don't know. Make game. How about that? All right, make game. Now this function here, I'm going to start with it at 0. All right. Let's come over here. We'll console log a game. Oops. game1 like this. Oops. We're going to run the function. Number, and I got to pass in a number. All right, so we'll pass in 0 to start with, okay? So we're at 0 so far, but let's say I come down here and I take game1. This is my new function that's been passed back by make game. I'm going to pass it something like 2. Well, now if I come down here and let's bring this down below and we take, let's see. Oh, I have to actually return something. I don't want to get into closures. We talked about that last time, but I need to actually have some kind of state in here that it returns. And that will pass back my new score. But basically what I can do is have this game1 where I pass in like a 4. We'll keep it as simple as the original example. And then I'm going to console like this, bring this down. We'll have a game2, and this one will be 5 or something like that. So now what I could do is take game1 and say, hey, what is my game1 score? My game1 score happens to be 0. I could pass this in. Whatever I pass in here, it's going to add to whatever the score started at. All right, so this game1 started at 4, and now I added 5 to it, so it's at 9. Now, game2 is its own separate thing, right? This function that I got back from make game, I started at F5. I added 2 to it, so now it should be at 7, right? So it kind of keeps track of its own state. Now, usually you would have some kind of closure where you're passing back a variable, and I don't want to get into that because, again, I want to keep it as simple as they did. But hopefully that kind of second example helps as well. Here what we're doing is we're saying we're going to create a function that gives us, that's tied to this particular game. And I can actually come down here. Well, yeah, no, I can't update it past that because the way we created it. But now we've got two separate, kind of separately tracked items, both by this function and this function that I've assigned to these variable names. So hopefully that helps. Okay, back over this way. We can even write functions that provide new types of control flow. So here they're going to pass in 2 items. There's a test, and then there's a then, and they're saying if test is there, then do test. Otherwise, or sorry, if there is no test, then do then. And then we're going to go ahead and repeat this here, right? So all of this, no, this is a separate thing. Okay, so we're going to say unless n is other than 2. Yeah, okay, here we go. So we're pulling this function in and saying if n modulo 2 is equal to 1, if this is true, then we're going to pass back this console log is even, right? So now when we actually console log this, here we've passed in 3. So we're looping through this and basically saying only if it's even, then do that, right? Otherwise, it just doesn't do anything, right? So it doesn't do anything with number 1. It doesn't do anything with number 3. If I change this to 7, we should get a couple more logs, right? 0, 2, 4, 6. But basically this flow, this control flow, basically says whatever function I pass in here, which is this right here, this function will only run if the test is not valid, right? So if it doesn't like fit its thing right here. So you can actually change whole control flows as well. The noisy XY syntax pattern is pretty powerful, but I almost never see higher order functions used in library APIs. Why do you think that is? I don't know. I don't know if it's just like there's complexity to it, and so it becomes hard to read, or if it's just like common patterns, like what people fall into. I'm not really sure. But yeah, I feel like they should be used more than maybe they are. But JavaScript also gives us lots of higher order functions. Okay, we're going to skip past this. I didn't find it that helpful. So now what we're going to do is look at a couple of higher order functions you could create, but they actually are built into JavaScript as well. And that's why they're built into JavaScript, because JavaScript realized, hey, people are doing this a lot. Let's just build this into the language. And that can be really nice. So here you see we've got this one for filtering. You pass in an array, you pass in a test, and it basically declares here this array called passed, and then it does this loop and it returns whatever passed the thing, right? So this would not be hard to create yourself. However, you don't have to do it yourself because there's actually one built into JavaScript. So let's copy this over and look at this as well. So I've got this filter thing, and I could say, let's call console log. We pass an array like on a 1, 0, 1, 2. And then we pass in a test. So this would be something like if n is greater than 0 or something like that. 2 is greater than 0. What are they passing in here as an example? Oh, script.living. Okay, so they're looking in here. Okay, if it's false. So they're basically passing each of these things and just returning one of them out of it. So I'd have to have some kind of like thing I'm looping through in this case, where I have an array and my test is like, yeah, whatever it happens to be, then it's going to pass out of that. Well, the nice thing is we get this by default out of JavaScript or from JavaScript. So if I have like 2, whatever, I can filter off the back of this, and it's the same kind of thing. You'll notice I pass in a value, then I pass in, so whatever the value happens to be, I can name it. And then I just pass in some kind of test, like if n is less than 2, right? So out of this, I should get, if I console log this, let's see, one more, like that. I should only get 0 and 1, right? It filters out anything that doesn't match my criteria right here. So this is built into JavaScript, so you don't have to write it yourself. The same thing is true of these next couple ones too. Hey, Fuzzy, welcome back. We also have a map as well, where you just want to do something to each item. I think of maps as like little factories. So filter, you're saying what fits my criteria. Map, you're just saying every single item in this array, in this thing that I can iterate over, I want to do something to it. So here's their example of writing it out themselves. You pass in an array, and then you pass in something you want to do to it, all right? Transform it in some way. This would be some kind of function you pass in. Whatever function this is, in this case, they're saying, where's my function here? That's not name. Oh, they're still working off of this up here. I find that confusing because you're like, you don't know what they're talking about, and they don't actually bring it up again. This is why I didn't go over that. But here, then they're returning what you'd expect here. But we get the same kind of thing in JavaScript. So if I come over here, we could also map over these. And maybe let's leave that there. I'm going to console log. We'll have a new array. Here we'll say like Chris and Joe or whatever. We're going to map over these. And again, a map is just it's like a little factory. Unlike filter, which filters stuff out, map is going to say, do something to every single item. Now, again, I have to provide it some kind of variable name. So let's call it like n for name. And then I just want to do something to each of these items, if I can type. So we're going to say n dot to uppercase. So this is my actual function I'm passing in. And I'm saying do this to each of these items. Readings map. What did I mess up? Syntax. All right, so for each of these, I'm going to take them to uppercase. So it's a function. Each item in this array, do this one thing to it. So filter takes something out. Map does something to every item in the array. Now, there's this complex one that often you can get into trouble with. It's called reduce. A lot of times what you want to do is compute a value, a single value from an array. So the recurring example, summing a collection of numbers is an instance of this. Another example is finding the script with the most characters. A higher order operation that represents this pattern is called reduced. There's a lot of people who don't like reduces, again, because they can lead to easy bugs, or you can like make really slow functions. So you have to be careful with them, but they are really powerful. They are legitimately, I think, like the most complex built-in method in JavaScript. So if you don't get this, that's totally fine. But basically, filter and reduce, you're going to use filter and map, you're going to use a lot. So filter is just taking something out. Map is just doing something to an array each time. And again, you can write it yourself if you want to, but why do this every time when you can instead just use .map, right? And they build that for you. See the reduce 2 episodes ago. That's right. Yeah, I did a video, I don't know, a year and a half ago or two. On reduce because I messed it up in a live stream and I was like, I need to figure out how to do this. And then I don't use it a ton just because a lot of times I think they cause more issues than they help with. But there are times like grabbing a number off like a list of objects or something like that, summing those up, like that could be super helpful. So here we're taking an array, we're having some kind of combination. I don't know exactly what, I got to read what it's doing here. So we have an array, we're passing that in, some kind of combination. Okay, we're taking the first and then the second item, and then we're adding them together, and then we have a starting point. Okay, so we're going to have the current start at start, whatever that starting point is. In this case, it would be 0. And then for each item in the array, so we're going to combine them. So this function, we're actually passing in down here and using this to combine them, and then we're returning whatever the current one is, which by the end of this for loop will be the combination of all those numbers. So this is complex, but so is reduce, which I mean, like the built-in reduce. But this is what it's doing kind of behind the scenes. Generator functions, I know, right, Fuzzy? Yield something, right? I did mention generator functions a moment ago and said, don't worry about them right now. But yeah, so we can do this ourselves as well, just using the simple reduce. Now this, they're showing how to do this. It's the array method, which of course corresponds. Okay, so you can use this reduce where you pass in an A and a B, and then you add them up together, right? So it's just saying add all these things up. And here, the point of reduce, map does something to every item in the array, but it gives you back an array. Filter takes out items in an array, but gives you back an array. Reduce takes in an array and can spit out anything, basically. An object, numbers, whatever you want. So it's going to take each item in the array, do a bunch of stuff to it, and return back to you whatever you want it to do, which you need to do a lot in JavaScript, so it can be really helpful. To use reduce twice to find scripts with the most characters, we can write something like this. I promise you this will be more complex than you want to know about right now if you're just learning JavaScript. Okay, so we're going to pass in some kind of script. We're going to return this script, .ranges.reduce. We're going to count. This is our, what did they call it up here? Yeah, the array that we pass in, whatever items we're passing to start with. Then we're having a from and a to. They've destructured these as an array. Again, like I said, this is going to be more complex than you want. And then they're simply counting. And then this is also being returned. So there's a function that's being returned, that's a reduce, that's returning to you. And it's going to be a number that they give you at the end. I won't go a ton into reduce here, but maybe I'll just mention, let's walk through a quick example ourselves here. Okay, yeah, we can use that actually. So let's do that. So I'm going to come up here. We've got our peeps. Okay, so all these people have an age. Let's combine all of their ages. How would you do that? Actually, let's do all three of these. So we've got peeps. So I'm going to console log this. We're going to say peeps dot, and let's first filter. So what do we want to do? Well, let's see. Let's name each of these things. Each of the objects, we're going to just name object because that's what it happens to be. And then I only want to return things that match this criteria. Maybe we could just say like object.age is like less than 24, something like that. So now I should get back an array with just these items. We've got age 22, age 18. So that one worked. So you see how we got this really nice little compressed thing. Now, of course, we could write this ourselves if we want to. That's what they did a moment ago. If I come back over here, thanks, Fuzzy. Here's their filter. You could write all this yourself every time, or you could just use .filter, right? So they've already written the function, this higher order function that basically takes in a function and in an array, and then basically uses that to transform some data in some way, in this case, taking things out. So this would be an example of using a filter. Let's use a map now. So we want to do something to each item in the array. So we can say peeps.map. We're going to take each person, which we'll just name P. You can name it again, whatever you want. So this is the item in the array that we're looping over. And now what I want to do is for each of those items, I want to do something to that item. So maybe I'll take, I don't know, let's take the p.name, and we're going to just simply return off of this. The syntax here is not super important right now. You'll figure this out as you go. If you're just learning JavaScript, it's just the thinking that's helpful. We'll do like the greatest, right? Whatever that happens to be. And now if I come down here, we have Chris the greatest, Terrence the greatest, Megan, okay, et cetera, right? So all these are now showing up. They're all the greatest, all right? Because we've done something to each item in that array. Okay, lastly, let's do reduce. And what we want to do is maybe take all their, let's start with their age, and then we'll also do all their favorite numbers if we have time. I don't know. Now we're probably just wasting time because if you're just learning this, it's probably too complex to jump into, but we're going to take peeps.reduce, and we're going to pass in each of these items here. So reduce, if I jump back this way, let's kind of get the lay of the land again right here. We're going to take some kind of array. We're going to take whatever like function will do things to it, whatever we want that to do. And then we're going to have some kind of starting point, right? So the starting point is also going to be the type of thing we want in the end. So here you see they've passed in an array. They've passed in some kind of function to do something to it. And the starting point is a number, which signals to me at the end, I'm going to get a number back. And you do the same kind of thing in reduce. So if I come back this way, in fact, they have this example right here, right? You take a reduce, you pass in this starting point. I'm getting each of these items from here, and I simply pass that back out. All right, so inside here, we're going to have, usually I like to, man, Sorry, let me grab some water. For each of these items in the array, it works just slightly differently here. We'll take each of these items, we'll just call it P for peeps. Then we have some kind of current value, like the accumulated value to this point. I usually call this ACC. And then we can pass in the index. I don't really need that. So then out of here, we can do a more complex thing or an easier thing. Let's start with the more simplified thing. There we go. Need another log there. So all we're going to do is return out of here. And what I want is to return the ACC plus, and then I need to provide something I'm adding up. In this case, it's the P, the item I'm looping through, .age. Now, the last thing I need to do is provide it a starting value. So the last thing here is to provide it something like that, okay? So now I've got the thing I'm looping over, in this case, the person. I guess we can call this person just to make it clear. We've got the accumulated value to this point. And then we've got the starting point value. So same kind of thing, right? That we just saw in that kind of made up function as well. What did I mess up here? Do I already have a person? Oh no, what did I mess up? P.age, reduce. We had it a second ago. I don't know what I messed up here. Fuzzy got me again. Yeah, I mean, all I'm wanting to do is basically add up each of those ages, each of the items in the age, right? So I don't know what I'm messing up here. Again, I don't use this a ton because I don't think it's always super helpful. This should be just the person, the item I'm looping through, the actual return value. So I'm clearly doing something wrong here. But I don't know what it is, so. Anyhow, you can use reduce to go through that. I guess I'll have to go back to the drawing board and reduce. But the whole idea is you want to get something in the end. In this case, you can see they're reducing all these numbers down to one number in 10, and that's what you want in the very end. Okay, composability. Consider how we have written the previous example, finding the biggest script without higher order functions. This code is not that much worse. So we'll say get the biggest, we'll set it to null to start with, and then we're just going to loop through all the scripts and basically figure out which one's the biggest, and we should return that, right? So there's a couple more bindings. The program is just 4 lines longer, but it's still very readable. The abstractions these functions provide really shine when you need to compose operations. All right, as an example, let's write code that finds your average year of origin for living in dead scripts in the data set. So now we're going to have this average function that takes in an array and returns a reduce, right? Where it's going to return the computed value of the reduce, an array. In this case, it'll an average. In this case, it'll give us a number, right? So now what we're going to do is take math.round, which itself is this kind of higher order function. It's going to take in this average where we pass the scripts.filter. We filter, first of all, to those that have a year that are first living. Then we map over those items, right? And then we pass that to our average function. So in other words, we've got this round, we've got this average, which is itself is a higher order function. We've got filter, which is a higher order function, and map. So we can kind of like piggyback these one off of the other. So what I'm doing is this array that I'm getting here is the array that first of all contains any of these scripts that are living, then any of these that have a year to them as well. So only if they have a year and they're living, the only thing I'm getting out of here is their year. So I'm stripping out everything else but their year. And I'm passing this an array of years. Then I'm using that to simply average up all the array of years, right? Same thing here. We're taking math.round, we're averaging all these. We're taking this filter, we're filtering off and making sure it's living. Then we're passing along the years, same kind of thing, right? So this loop is way more compressed, right? Right here is way more compressed than what you could do, which is all this, I'm guessing. Right? You could write this as one huge loop as well. Yeah. So you could write the same thing as one huge loop. But these kind of piggybacked things allow you to do stuff way more compact. Plus, once you learn how to use these, like filter and map, it's very clear. Okay, I'm filtering first, then I'm looping over each item in the array and only returning the year in this case. It's hard to see what's being computed and how. Because the intermediate results aren't represented as coherent values, it'd be a lot more work to extract something like average into a separate function. In terms of what the computer is doing, these approaches are also quite different. The first will build up new arrays when running filter and map, whereas the second computes only some numbers, doing less work. You can usually afford the readable approach, but if you're processing huge arrays and doing many things, a less abstract style might be worth the speed. So in other words here, we're doing less work, like it's less heavy than it is with this more compacted version. So sometimes you have to worry about that. Right now, you don't need to worry about that, okay? Strings and character codes. One interesting data set, I forgot to read our summary to start with. One interesting use of this data set would be to figure out what script a piece of text is using. Let's go through the program that does this. The only reason I don't like this whole script thing is because you have to keep coming up here and being like, what did I have up here? I had names, all this kind of stuff, but I don't actually see the full set. I only see one object. And it doesn't show me that anywhere, I don't think. Yeah, so it's just not, it's not super clear what's happening. What do you think is bad advice from the book, Fuzzy? I think at this stage, if this is what you're saying, like to think about, like readability is the only thing that matters when you're learning. I think like you should not be concerned about what's the computational time of this thing. Like that's not important if that's what you're saying. It just ends up making people make really compacted functions that they're trying to make super compact, pure as it does one thing with no side effects. That is also true. Yeah, and they do talk about pure functions. They've actually talked about it a couple times already in this chapter, in fact. But yeah, assuming that that's what you're saying. Okay, remember each script has an array of character code ranges associated with it, given a character code. The example up here is side effects. Yeah, because it's altering stuff outside, yeah. All right, let's go through the program and see what it does. Remember that each script has an array of character code ranges associated with it. Given a character code, we should use a function like this to find the corresponding script, if any. So here we're going to pass in a code. We're going to just look through them and determine if any of these exist, and if so, return that entire item, right? So you'll notice here we're talking about the way strings interact with these. The sum method is another higher order function. So we've looked at map, we've looked at filter, we've looked at reduce. Sum is another one of these that essentially does this. What it's going to do is check to see if this exists, right? Ranges.sum from ranges, what is this? Again, I got to scroll all the way back up to see anything it's doing. Ranges, okay, here. So it's checking inside this array of arrays, all right? So this is really helpful with that kind of matrixy ID here. So it's looking inside of these ranges. This is an array, and it's basically figuring out if any of these things exist. If anything exists in here, this will return true. Otherwise, it will just return the script as a whole, or false, or it will return. If this sum to, yeah. All right, how do we get the character codes into a string? In chapter 1, I mentioned that JavaScript strings are encoded as a sequence of 16-bit numbers. These are called code units. Unicode characters. I don't know if this is super helpful at this stage. Obviously, interpretations on JavaScript get their strings wrong. Basically, like when JavaScript coerces stuff, it's not super helpful. Like, and then Unicode characters are counted differently. I don't know why they're bringing this in at this point. I did not get to this point in the reading so far. Character code at method. This is another. So they're just showing you different methods, I think, at this point. Okay, so we've got a sum method. We've got a character code at method, which tells you exactly where the character code is in like this item. So each char of, mentioned for of loop, okay, can be used on strings. That's true. It basically breaks the string up into arrays, into an array of items. So yeah, so let's look at the sum one real fast, just so we have it here. I'll say like Chris, Joe, whatever. And then I can just say like sum, and I'll name this something like n. And I could say like n equals Chris. And this should get me, oops. Console, oops, .log. And all this is going to say, do any of these items have something in there? Now, named Chris. The other thing I can do is say every, this is another one. Does everything in this equal Chris? No, everything does not. So there are a bunch of these little methods on here, and you'll see these whenever you're working with an array like this. You'll see we've looked at filter, we haven't looked at find yet, but I could also do find. And here all I want to do is find the string Chris, I think. No, I have to actually pass in a function, right? So we're going to have like name and Chris, and it finds Chris. Yeah, so it finds the very first instance of Chris and passes that back to me. So there are a bunch of functions. That's what they're telling you. And they miss on, hey, Arthur. Yeah, you're welcome to watch. I kept the stream up so you can watch it later if you want to. If you gave, you did win something if you sent me your receipt. And so hopefully you won something if you gave. All right, so all they're showing is like you've got different things like character point at is another one of these methods. Sum is the one they showed you up here. All right, recognizing text. We have a character script function and a way to correctly loop over each of the characters. We've got items, we've got group by name. So they're grouping these items in the array. The count by function expects a collection, anything we can loop over with for of, and a function that computes a group name for a given element. It returns an array of objects, each of which names a group and tells you the number of elements that were found in that group. It uses another array method, find, which goes over, oh, that's the one we just looked at, goes over, so they're just showing you different methods at this point. So we've looked at find, we've looked at, what was the one we just looked at? Character, code car at, length is another one, sum. So all these are just methods that are attached. These are higher order methods where they'll either take a function or return a function to you. So count by, they're just showing you a function that tells us which scripts are used by a piece of text. So here, see if they're using any of these. We got one higher order function here with reduce. Math that round. And yeah, they're basically just showing you different options here. We won't go through that example right now. Maybe we'll look at some examples over here where we can play around with stuff. So being able to pass function values to other functions is a deeply useful aspect of JavaScript. It allows us to write functions that model computations with gaps in them. The code that calls these functions can fill the gaps by providing function values. So you can pass functions, you can also get back functions as well. Arrays provide a number of useful higher order functions. You can use the for each to loop over each item in the array. The filter takes out things and passes back a new array. You can use the map to do something to each array and pass back a map. You can use reduce to get back a number or an object or an array or whatever you want. Basically, you can do a bunch of stuff to it and just once you're done reducing everything, give back one single value in the end, whether that's an array or a number or whatever. Then you have other methods, especially connected to text is what they were showing. The sum methods test whether an element matches the given predictive function. Find finds the first element that matches that thing that you pass on, whatever that happens to be. So these higher order functions are kind of crucial to the way you interact with data in JavaScript, whether you're writing your own or whether you're just using the built-in ones, which you're going to use a lot because they're built in for a reason. All right, maybe let's look at a couple of items here. You can use the reduce method to combine with concat in combination with concat method to flatten an array of items into a single array that has all elements of the original arrays in them. Well, you can actually do this in a bunch of different ways, but we can take arrays. Let's see. I got my first student job paycheck thanks to Astro. Awesome. That's cool to hear, Arthur. Yeah, you can. It's free online, so there's a link in the description. So they're saying we use reduce here. And we're going to pass back. Actually, one thing that's really helpful when you're learning MDN or reduce, always check out the MDN docs. These are super helpful. They walk you through how something is used. And one of the biggest, like obviously there's a ton of things here you can get into. One of the best things you can do as a developer is learn how to read documentation. Here we're reading a book describing it, but it's the documentation that's also really helpful. And MDN is kind of the source of truth for a lot of JavaScript stuff. So maybe let's walk through this here as an example, and then we'll go back and see what we can do, right? So we'll take this array here, and they say that we've got this initial value we're going to reduce over this. This initial value here, I don't know what they're doing with this because it's not used. Oh, okay, they're just passing it in down here. Okay, so array.reduce, it's going to pass in this function, right, that has the accumulator and the current value. Did I put those backwards on the last time I did that? I think so. So the accumulated value to this point, and then the current value, the individual item we're looping over. So like 1 or 2 or 3 or 4 or whatever. And we're simply going to add those things up. And then we've got this initial value that we're passing back. Or that we start with, right? Which happens to be 0. Usually I would just write this like this, where I pass in 0 down here, right? So in the end, this should give us back 10, and it does. So again, the array method or the reduce method is going to take in several things. Now, one of the things that's really helpful to know is what items can I pass in here? So here it's saying a callback function and an initial value. Callback function, it's going to talk through the different things inside that callback function. So there are 4 items you could pass in. Usually you just do the first 2, but there are times where you need the index or even the whole array. So here you're going to pass in the accumulator. This is and the initial value. The first time through, it'll be the initial value, but it's the last value from the last time the loop was run. Then you've got the current value, which is whatever the item is in the array. You've got the current index if you want to know it's the second item you're looping through or the third item you're looping through. And then finally, you can pass the entire array if you want to and do stuff to that. Then you've also got the initial value, which is optional, but usually you kind of need to know what that is because that's what your accumulator starts with. And usually you start with that initial value just for clarity's sake. Again, if that doesn't make a ton of sense, that's totally fine. Where's our actual example? Right here. All right, so let's come back over here. So now that we know what that is, we've got the accumulated value to this point. We've also got whatever the number we're looping through, the array we're looping through at this point. Why don't we simplify this first? So let's do a simpler one and then we'll come back to this. So we're just going to say array. I'll just do it like that. We're going to start with 1, 2, and 3. So we want to add these things up. Oops. All right, so let's start with that first. And then we'll do like kind of this double loop inside of it. Or I guess it doesn't have to be a double loop, but so we want to flatten this thing. Here I was going to add it up. I forgot we were flattening. Anyhow, we can add it up. All right, so here we're going to start with our initial value at 0. And all I want to do is add up each of these items. So I'm going to take the ACC. I'm going to add whatever it's not an array anymore, it's a number like this. And when I run this and I wrap it properly, this here, pass here. Let's see if I can get all my things right. There we go. So I get 1, 2, what do I get back? I need to console log this so you can actually see it. Console.log. We've got array reduce, and we've got 6. So all we're doing is taking the accumulated value, we're adding a number to it, we're starting with the number 0. So again, kind of what we just saw almost in the MDM docs. Let's come over here. And let's add this here so I can actually get some of my IntelliSense over this way. So we're going to console.log. Actually, let's just name this like a new array. Okay, and this is going to be equal to my arrays dot reduce. And what I want to do is use both the concat method to combine different arrays, which I don't ever use, but that's okay. So we're going to do that, and then we get to pass it some kind of initial value to start with. So in this case, I'm going to start it with an empty array. Now I know that each time I loop over this big array, this outer array, I'm going to be passing it an inner array, right? So we're going to call it the kind of accumulated value, I'll just call it ACC, and then we've got the inner array. So whatever inner array we happen to be on, so I'll just call this ARR, okay? So for each of these items, what I want to do is basically reduce them down by adding them to this accumulated value so far. So I just want to take all the items and add them to there. Now, you can use the concat method. I usually would just spread this in. So I would take the, return the ACC, dot push, and probably I would just, let's first of all push it like this. Console.log, the new array, like that. Oops. All right, so the ACC should be, that's fine, we can do this. So right now, if I pass this in, I'll get nothing back, but I could also take whatever the current array is, and I can spread in the array. like this. All right. So if I do that, it's just going to spread it in as you'd expect. I'm spreading the ACC, whatever it currently is, and then I'm adding each of those. So I'm just essentially duplicating it at this point. But I could also take this and instead of spreading it inside an array, spread it like that. It's the same kind of thing, right? So this is actually what I want. Or you can concat them, which is what they were saying to do. Concat these two. Is that how you do that? Yeah. Concat. Oh, I think I have to take the acc.concat. Yeah. And take ACC. I don't even know how this works because I use it so infrequently. And the array maybe? Like that? Kind of. So no, that doesn't work. So I don't have to pass back in the ACC. Just that. Is that right? Okay, there we go. So I can concat it instead. I usually spread it in, although I'm assuming concat is more performant. But yeah, so you can combine these arrays and you're taking the existing array and combining it with whatever the other ones are. So we're flattening it in that sense. All right. Your own loop, write a higher order function loop that provides something like a for loop statement. I do need to go in like 3 minutes. I didn't realize the time, so I probably shouldn't try this, but take a shot at some of these things as well. I think last time, if I remember right, I kind of bombed out on these examples I gave you. Let's see if I can go all the way back in the history. And maybe we could do one of those real fast. Yeah, okay. Yeah, so we had... Yeah, let me get rid of all this. Okay. We had some examples here, and these would be other ways to test your methods or your things as you go through them. Add a Boolean property is awesome for each peep and set it's true if the person has at least 3 favorites. So this way you would loop over each item and do something for each of those items. So like a for of or whatever you want to use there. You could use a for each loop as well. Return a new array called young peeps with peeps 25 or younger. That would be a classic filter method. I think that's actually the one somehow I didn't get right last time. I don't know. It's hard when I do these things because I'm doing it like 5:30, 6 in the morning. And like some nights my kids get me up in the middle of the night. So that's my excuse for whatever happened last time, but it wouldn't be the first time either. So we're going to say young peeps. And as an example for like another one we could do as a filter, since we already talked about filters. I'm going to have young peeps equals, and we're going to take the peeps, which is our array up top, dot filter, and we're just going to say for each person, only if they pass this test do I want them in this new array. So it's going to give me a brand new array. And this would be if the p.age is less than or equal to 25. All right, so now I should just have in this young peeps array, whatever these people are, right? Did I do that wrong? Less than if they're less than or equal to 25. Yeah, that should work. Okay, here's the new young peeps array. So here I'm just getting back the people, right? So you can take these and I'll make sure to include a link down below. You can sort. There's a sort method as well. Return true if every person has an age. So this would be that every method I showed you. Find a function called find peep that returns the peep for the ID passed in and returns not found. So here what we're going to do is we're going to write a function called peep. I should do one of these challenges where you're writing your own higher order functions. That's what I should do instead of just using the existing ones. So I'm going to do that. That sounds like a good way to kind of cement some of this. For me, even though I've done this before, I don't write a ton of higher order functions, and I think I probably should more because they are kind of a superpower. Arthur, how you doing? I was wondering what you studied. I already said, I've already said this, I think, but I love the new background. Oh, awesome. Thanks so much, Arthur. Thanks to Work for providing it for me. I did not study anything related to this. I'm all self-taught, like a lot of people. Self-taught is in like learning from other people, but not formal schooling. So, yep. And it sounds like that's where you're at too. Or maybe you're actually working you're on a student job paycheck. So I'm guessing maybe you're a student in computer science or something. So, yeah. All right, well, cool. Well, this was a fun one. Maybe I can do some challenges around higher order functions and like what functions you might want to write. So that would be kind of cool. Maybe I could have you write your own for of loops or like repeat. Reduce, filter, map. Those would be cool. Your own sum. Yeah, we should do that. We should have it where you write your own. And of course, they're like competitions to like how compressed can you rate this? And a lot of times these are on like coding interviews and stuff like that. So it could be helpful in that as well. First year of engineering, awesome. In 2 years, you're going to look back and say, man, I've learned so much. In 2 months, you're going to say that. And that's a really fun place to be. So cool. All right. Well, thanks so much for following along. And I will catch you next time. I'm away next week a lot at a conference, and then I'm back for a week, and then I'm away again. So it's going to be a little spotty, but I will plan on, I don't think I'm going to get to chapter 6 until next Friday. So that'll be the next one we do, but maybe I can throw out a video this Tuesday or something on writing your own higher order functions. That would be kind of fun. Okay. I will catch you in the next one. Thanks for watching. Happy coding.